before I define line of fit, what's up, Ayala? Okay. So before we define the line of fit, don't write this down. I just want to talk about something real quick. Let's say I want to study you guys. Okay. Let's say I want to study how much time you guys spend texting. Well, how about this? The number of times texts per day. It's the number of texts per day. And then on this, on the vertical axis, maybe your GPA. So look what I'm doing. I'm taking two variables about you. The number of texts per day. So you might, I'm not sure how many you, okay. But not only your texts per day, but also your GPA, your grade point average. What's a straight A GPA? You guys know what the straight A GPA is? 4.0, right? So you got 1.0. So just pay attention. You're not writing this down. I want to show you where I'm headed here. Okay. So if you're a straight A student, you're going to be a 4.0. Now, what if it was a case that, ready? What if it was the case that, let's say, let's go 10, 20. Like the more texts that you do in a day, the lower your GPA. What if that's some type of trend that I actually find out? If I start plotting everybody at Park West, what if I start seeing this? In other words, every dot here represents a student. This would be I'm not saying it is, I'm just hypothetically. Let's just say that the more I find out that whenever I plot the number of texts in the GPA of every student at Park West, I see a downward trend. In other words, the more texts, the lower the GPA. Look at these kids that text most have the lowest GPA. Whether this is the case or not, that's yet to be found out. We're going to do our own study of Park West students later. But what we call this is called a scatter plot. Scatter. You have a lot of dots that are plotted and they're all scattered all over the place. So we call it a scatter plot. It's data. It's information. Now, here's where we're headed now. We're going to take scatter plots of data. And what we can do is we can describe the data, Castro. We can describe the data with a line. Because notice, if I drew a line, put it in red here. Right, if I drew a line that's as close as possible, look at it, as close as possible to all the points, maybe about right here. We call that a line of best fit. So if I were to draw this line, then create the equation of this line, the equation that I create of the line, and you already know how to create equations of lines. You know how to do it in point-slope form and slope-intercept form. If we're able to write the equation of the line, we can kind of describe and approximate the data. Yeah, it's like an estimation of this data. So if I were to write the equation of this line, that equation describes the data approximately, obviously. Because it's not perfectly a fit of all the points. It's just what we call a line of best fit. So notice, your first word is called line of fit. And here's what you're going to write. A line that approximates a set of data. And write that in there. A line that approximates. So the key word here is approximates. While you're writing that down, a line that lies as close as possible to all the points of a scatter plot, I'm going to pass out one sheet of graph paper because we're going to create a scatter plot. And we're going to draw a line of best fit. I'll show you how this is done. That third word we're going to define tomorrow, so make sure you're not absent tomorrow. Correlation coefficient. So right now with your graph paper, go ahead and copy this plot down. Go ahead and copy that scatter plot. Yeah, let me get you in. Go ahead, Gomez. Okay, so on the other side of your node guide, flip the page. So you have your node guide in front of you and the graph paper in front of you. Notice what it says, finding a line of fit, right here on the other side. Rodriguez, can you read step 1 for me of finding a line of fit? Good. So the scatter plot of the data is already done for you. So step 1's done. It's right here. There's a scatter plot. There's a bunch of dots that are plotted and they're scattered. Hence the name scatter plot. Beltran, read this step 2, would you? Okay, so there's a trend going on. The higher the x value, the higher the y value. Notice it's going up. As opposed to the GPA and texting example that I made up, there's a trend going down. The more taxes, the lower the GPA, so we call this a downward trend. This one, there appears to be an upward trend. The greater the x value, the higher the y value. To a degree. Okay, it's about an upward trend. Not exactly, but it kind of, things are starting to go up. The higher the x value, the higher the y value. So Ms. Beltran said, sketch a line that closely appears to follow the trend. There should be about as many points above the line as below. So I'm going to draw a line. Don't draw yours yet. It's okay, here's my line. So I want to draw a line that is as close as possible to all the points, making sure that there's about as many above as below. Okay? So, here's what I'm going to do. So look at that line. Is there as many above as below the line I just drew? How many are above it? 3 above it and 3 below it, huh? So I'm going to keep it there. Now, this is my line of best fit. Yours may be slightly different. As long as it's somewhere near here, you're going to be okay, because this is all approximation only. This is just approximating. And the best way to approximate is just to make sure that your line has the same amount of points above as below. If you do that, it's about as above. It's not going to be exact all the time, but as long as there's an equal amount above and below, you're going to be okay. You're going to get the right answer. You'll have a good line of best fit. So what I'm going to do is I'm going to leave mine right here. Here's my line of best fit. So go ahead and draw yours. My y-intercept is about 2. So go ahead and draw a line like I did. The line crossed the y-intercept at 2, and it crossed this point, which was what? 5, 5. Did I give you one? Here you go, Valdir, I got you. So go to copy my line of best fit on your notes. You guys already know how to write equations. We'll do slope-intercept form. Normally I'll specify, so let's go ahead and write the equation of this line in slope-intercept form. So y equals mx plus b, right? So what is the line that describes this data? Approximately describes this data, Castro? Ready? Let's find the slope first. Delta y, delta x. We could do this in our sleep now. Castro's probably doing it in her sleep. Go ahead. One more time? You sure? We just need to pick two coordinates, huh? On the line. 0, 2. Right? So I got 0, 2, the y-intercept, and I got 5 and 5. So delta y is 5 minus 2. Delta x is 5 minus 0, huh? 3 over 5. There's my slope. So what's the line that describes this data? Well, here it is. We got our slope. We got our y-intercept. Where did it cross the y-axis, Naheda? Where did this line cross the y-axis? Hold on. Thank you, Naheda. Wait till I call on you, please. So, 2. The y-intercept is 2. Let's do it. Y is 3/5 x plus 2. So this line approximates the data. Notice. It would be the line of best fit. Now the cool thing about this, once you have the equation, you can predict the future. If you want to know approximately what would be the y value if x is a 100, well, all you got to do is replace x with 100 here and figure out what the y value would be. What would the y value be according to this trend if x was 1,000? Way out here. Where would the y value be approximately? Well, just replace x with 1,000. You can figure out the y value. Now this data is very vague. It doesn't specify what the x and y mean. But in real life, like the one I gave you, GPA and texting, I can kind of approximate what the GPA of a student would be if they had 100 texts, let's say. So it's like a way of approximating a reality if you get the line of best fit. One more graph. Going to copy this one down, last one for today. So the line I draw, I'm going to try to make sure that there's an equal amount of points above and below. I'm looking at these 3 points. If I were to connect these 3 points here, there'd be 2 points above and 2 points below. So it looks like a good fit there. Right, Valtierra? 2 points below, 2 points above. Looks fair. Again, your line may be a little bit different than mine, and that's okay because this is all approximation. Approximately, what's the line of best fit? This looks good to me. Let's write the equation now. Here we go. So there's a line. Y is mx plus b. Our slope, delta y, delta x. Excuse me? On the line, huh? Not on the scatter plot, but on the line now. Right. So on the line, any 2 points. Look, here's my y-intercept. And you have 3 points to choose from, exactly. Remember, we could do that, any 3 points. How about that point and that point to find the or the slope? Doesn't matter. So that would be, let's see, 5, 1. And this one would be 4, 2. Let's find the slope here. The rate. So delta y, 2 minus 1. Delta x, 4 minus 5. Yeah? 2 minus 1 is 1. 4 minus 5 is negative 1. So the slope is negative 1. Well, that makes sense. Fall 1, run 1. Fall 1, run 1. For every negative vertical unit, there's 1 positive horizontal unit. Negative vertical, positive 1 horizontal. So hence the negative 1 slope. That makes sense. Y-intercept. Gomez in the back. What's my Y-intercept? You're killing me. Brian Gomez. 6, huh? Here's your Y-intercept at 6. Crosses the Y-axis at 6. We're ready to rock and roll. Y is negative 1x plus 6, but making it more professional. This is why Mungia wears a tie. Negative x plus 6. If we're professionals. Line of best fit. Tomorrow I'm going to talk more about what the heck the correlation coefficient is. What is this correlation coefficient here, that third word? I'm going to talk about that tomorrow. For now, work on 5 or 6. 6 is from the computer. It's a new website. You'll do a lot of the rest of your assignments will probably mostly be online now. And there's directions on assignment 6 of how to log into the website and submit your answers via the World Wide Web. Okay? You guys are millennials, so you guys know how to do all that stuff.